The Hadean Eon is a mystery. It's a mystery because the Earth was molten at that time and all the clues were destroyed. Different-minded geologists and opposing geological societies have divided it differently. To simplify things, I've divided the Hadean Eon into the planetary, lunar, oceanic, and granite eras. The topic of this discussion is the lunar era. The lunar era was a division of the Hadean when it's theorized that the moon was formed. Let's picture the nascent solar system 4.533 billion years ago. Planetoids, mountain-sized boulders, continent-sized gold nuggets, iron, water, and a cloud of dust revolving around a young sun. We're fortunate because the sun has always been a main sequence G-star. In other words, it's calm and we should not expect any life-altering surprises. The inner four planets are dense, rocky, metallic orbs, dark and bumpy with mountains and valleys. The outer planets of the solar system are huge, gaseous, and smooth. It's apparent that the less dense gases were hurled far from the sun to make the gas giants. The heavy minerals and metals resisted the centrifugal force of the rotating infant solar system. This ore maintained enough of its gravitational attraction to the sun to stay close to the center. There's a notion that volatile gases, including water vapor, were destroyed from the heat generated by the formation of the inner rocky planets. These light gases could only accumulate in the frozen regions where the outer planets orbit, thus the advent of the gas giants. Then, according to this theory, after the inner planets cooled enough, meteorites and asteroids replenished them with water. It sounds plausible, but evidence gathered implicates several other sources for Earth's water. Mercury, at 5.4 grams per cubic centimeter, Venus at 5.24 grams per cubic centimeter, and Earth at 5.51 all have densities that reflect a combination of minerals and metals. Once we travel to Mars at 3.93 grams per cubic centimeter, we see that the dense metals are being left behind. By the time we reach the asteroid belt, we notice that the largest asteroid, Ceres, at 2.16 grams per cubic centimeter, is even more metal depleted. The origin of the moon is the next big question. At 3.34 grams per cubic centimeter, it seems to belong just past Mars. How did something so big as a planet, but so light, get into the mix with the dense orbs? The prevailing theory is that during the formation of the Earth, when the Earth was about 90% of its current size, a Mars-sized planet called Theia collided with it, sending the debris of both planets into a whirl that would eventually condense around the Earth as the moon. It makes sense, and this is probably what happened on many other planets outside the solar system. There is a problem with this theory when applied to our moon. Each planet has its own oxygen isotope ratio, and it's unique to that planet, like fingerprints. In the case of the moon, its oxygen isotope ratio is almost identical to the Earth's ratio. Furthermore, the moon's titanium isotope ratio mirrors the Earth's ratio. Certainly, Theia would have had different ratios, just as meteorites and asteroids differ from the Earth's, and Theia's isotopes would still be found on the Earth and the moon. Even in a planetary collision, Earth would not have liquefied, which would have erased all evidence. Therefore, the evidence for a collision is weak. What we have here instead is the discovery of a greater Earth-Moon connection. Looking at the density of the moon at 3.34 grams per cubic centimeter reminds us of another similar density, that of volcanic basalt at about 3 grams per cubic centimeter. Suddenly, our new clue takes us back to Earth to look for answers. The continents that we terrestrial organisms live on are called the crust of the Earth. The crust is where the mountains and forests can be found, and it's primarily composed of granite. Just beneath our granite continents are the tectonic plates composed of basalt. The crust and the tectonic plates are the upper and lower divisions of the lithosphere. Some geology texts use lithosphere in the same way our discussion does. However, some books prefer to place the crust and tectonic plates above the lithosphere, creating an extra layer. I am following the guidelines of the U.S. Geological Survey that say the lithosphere consists of the crust and our tectonic plates and rests atop the asthenosphere. The asthenosphere is a viscous layer of the mantle that creates the convection that moves our tectonic plates. To make a long story short, the density of the asthenosphere is 3.30 grams per cubic centimeter, almost exactly the Moon's density. The Moon has a small iron-nickel core. When small amounts of metal are added to the asthenosphere material, the density slightly increases. The same can be said for the lunar equation. The metal within the Moon increases lunar density to 3.34 grams per cubic centimeter. This lunar metal came from either the accretion of metals, like how the Earth receives some of its metals, or from the Earth, or both. So here are our findings. The Moon has the density of our asthenosphere plus some metals, and both the Moon and the Earth have virtually identical oxygen and titanium isotopes. Now let's visualize what happened 4.533 billion years ago. The Earth was rotating too fast for its gravity to hold onto all its mass. Centrifugal force dislodged a glob of molten rocky debris about 1.2% of the Earth's mass, give or take the Earth's slightly smaller size. 1.2%. The Moon's mass is 1.2% of the Earth's. All of a sudden, that stupendous, catastrophic grand blast that created the Moon instead now looks more like the Earth had a bowel movement. That mass that became the Moon was located in what is now the asthenosphere of the Earth. Earth had enough gravity to hold this molten mass in orbit, but even now the Moon is pulling away from Earth. This would explain the matching oxygen and titanium isotopes of the Moon and the Earth, and also answer why there's no evidence of Theia. There were surely many Earth debris collisions, but not a Mars-sized Theia collision that created the Moon. See you next time.